Jupiter does not look dangerous. That is the problem. From a distance, it appears almost peaceful. Vast bands of cream and orange wrapping around the planet like brushstrokes on a canvas. The great red spot sitting quietly in the southern hemisphere, looking more like a decorative marking than anything threatening. Serene, almost beautiful. But in space, appearances can be dangerously misleading. The moment any spacecraft gets close enough to matter, the instruments begin registering something that has no equivalent anywhere else in the solar system. Radiation, magnetic forces, pressures that have no business existing in open space. Jupiter is not a planet you approach. It is a planet that reaches out and finds you first. And almost nothing about it works the way you would expect. Start with the size, because without it, nothing else makes sense. Jupiter is the largest planet in the solar system by a margin that resists easy description. More than 1,300 Earths could fit inside it. That number sounds large, but numbers at this scale tend to slide past without landing. So think of it this way. If you emptied Jupiter and started filling it with Earths, one by one, stacking them like objects in a container, you would place our entire planet inside it over 1,000 times before running out of room. The oceans, the continents, every mountain range, every city, 1,000 of those, gone inside one planet. And that is just the volume. Jupiter contains more than twice the mass of every other planet in the solar system combined. Not twice the size of the next largest. Twice the total mass of all of them together. Saturn, Uranus, Neptune, Mars, Venus, Earth, Mercury, added up, multiplied by 2, and Jupiter still outweighs them. Mass on that scale generates gravity on a scale that does not stay local. It reaches across the solar system and rearranges things. You'd think gravity on that scale would be the headline. It isn't. Jupiter almost became a star. Stars generate energy through nuclear fusion, atoms compressed under such extreme pressure that they merge and release enormous amounts of energy. It is what powers the Sun every second. Jupiter never reached that threshold, but it came closer than any other planet in the solar system. Had it formed with significantly more mass, the conditions at its core could have ignited fusion. Our solar system would have had 2 suns. Earth's climate, its orbit, the conditions that eventually allowed life, all of it would have been different. Instead, Jupiter stopped just short. A world loaded with the right ingredients, where the process never started. What it became instead may be stranger than a star. Jupiter has no surface. There is no ground, no place to land, no surface waiting beneath the clouds, no point where air suddenly becomes ground. If you descended into Jupiter, you would simply keep falling. The atmosphere would grow thicker around you, the pressure climbing with every kilometer, the clouds giving way to denser clouds, those giving way to something that stops behaving like any gas found on Earth. Think of diving into an ocean that never ends, except the deeper you go, the heavier everything becomes. Not just the pressure, the material itself changes. Eventually, under pressures millions of times greater than Earth's atmosphere, hydrogen does something it does nowhere else in the known universe at this scale. It becomes a metal. Hydrogen is normally the lightest gas in existence. Inside Jupiter, the pressure becomes so extreme that hydrogen's electrons are stripped free and the substance begins conducting electricity like a liquid metal. An ocean, not of water, but of flowing, electrically charged hydrogen, churning deep inside the planet. Scientists call it metallic hydrogen, and it is one of the most exotic states of matter known to physics. That ocean of liquid metal is also what generates Jupiter's magnetic field. And that is where Jupiter becomes genuinely lethal. Earth has a magnetic field. It deflects charged particles streaming from the sun and makes life on the surface possible. Without it, radiation would strip away the atmosphere and sterilize the surface. Jupiter has a magnetic field too. The comparison ends there. Jupiter's magnetic field is about 20 times stronger than Earth's at the cloud tops, but its overall magnetic moment is nearly 20,000 times greater, creating the largest planetary magnetosphere in the solar system. Not a stronger version of the same thing, something categorically different. A force powerful enough to dominate a region of space millions of kilometers beyond the planet's visible edge. If you placed Jupiter at the center of our solar system and mapped its magnetic influence, it would extend past the orbit of Saturn. That field does not protect what is near Jupiter. It accelerates it. Charged particles become trapped in Jupiter's magnetic field and are flung to speeds approaching a fraction of the speed of light. They accumulate in enormous radiation belts surrounding the planet, invisible, silent, and capable of destroying unprotected electronics within hours. An astronaut in a standard spacesuit near Jupiter's inner moons would absorb a lethal radiation dose in minutes. NASA's Juno spacecraft carries a heavily shielded titanium radiation vault to protect its instruments. And even then, engineers must carefully manage how close it gets and for how long. Radiation is invisible. It leaves no visible mark on the planet. But it is everywhere, and the things we can see are no less extreme. The Great Red Spot has been observed continuously for about 190 years. It is a storm, a single persistent anticyclone, larger than the entire Earth. If you placed our planet inside it, the storm would swallow it completely with room to spare. When NASA's Juno spacecraft measured how deep it extends, the answer surprised researchers. The storm's roots plunge hundreds of kilometers below the cloud tops. It is not a surface feature. It is a deep structure embedded in the planet itself. And it is one storm among thousands. Jupiter's entire atmosphere is in constant motion. Jet streams race around the planet at speeds that dwarf the most powerful winds ever recorded on Earth. Bands of clouds at different latitudes move in opposite directions, the boundaries between them turbulent and churning. On Earth, storms dissipate because they run out of energy. Jupiter has no such limitation. There is no surface to create friction, no land to slow the wind, no mechanism to stop what has been spinning for centuries. The planet does not calm down. It never has. But Jupiter's most consequential power is not atmospheric. It is gravitational, and it extends across the entire solar system. In the early solar system, Jupiter's gravity disrupted the region where a planet might otherwise have formed between Mars and the outer planets. Material that could have assembled into a world was instead scattered, disturbed, and left as the asteroid belt. A collection of fragments that never became anything larger because Jupiter kept pulling them apart before they could. Mars itself may be smaller than it should be for the same reason. As Jupiter migrated through the early solar system, moving inward before reversing outward in a process scientists call the Grand Tack, it scattered enormous amounts of material that would otherwise have built a larger Mars. Jupiter did not just form in the solar system, it helped decide what the solar system would become. That influence continues today. In July 1992, comet Shoemaker-Levy 9 passed so close to Jupiter that the planet's tidal forces tore it apart, not into two pieces, but into a chain of 21 major fragments. For nearly 2 years, the broken comet remained trapped in Jupiter's grip. its fragments following one another around the planet until the final collisions arrived in July 1994. Each fragment was a significant object in its own right, and together they produced one of the most extraordinary collisions ever witnessed in the solar system. Those fragments struck Jupiter sequentially over 6 days, leaving impact scars visible from Earth, some nearly the size of our planet. Scientists estimate that without Jupiter's gravity intercepting objects like this regularly, the rate of large impacts on Earth could be significantly higher. The planet that shapes destruction also absorbs it. But Jupiter doesn't just dominate space around it. It reaches out and remakes entire worlds. Io, the innermost large moon, is the most volcanically active body in the solar system, not because of its own internal heat, but because of Jupiter. The planet's gravity flexes and squeezes Io continuously as it orbits. Imagine compressing a ball of dough over and over without stopping. That constant deformation generates heat, and that heat powers hundreds of active volcanoes. Io is being perpetually resurfaced, old landscapes buried under fresh lava within geological timescales that make Earth's geology look slow. Europa, the next moon outward, sits beneath a global ocean of liquid water, possibly containing more water than all of Earth's oceans combined, sealed under a shell of ice. Some researchers consider it one of the most promising places in the solar system to look for signs of life. But Europa orbits inside Jupiter's radiation belts. Its surface receives more radiation per day than a human could survive in a lifetime. Whatever might exist in the ocean below is protected by kilometers of ice. But reaching it means passing through one of the most hostile radiation environments humanity has ever attempted to explore. Even the most promising places here cannot escape Jupiter's influence. NASA's Juno mission, which has been orbiting Jupiter since 2016, has transformed our understanding of the giant planet. Yet one of its most surprising lessons is that every discovery seems to reveal a deeper mystery. A core once expected to be a compact, solid mass turned out to be a vast, diffuse region spread through much of the planet's interior. Weather systems thought to be relatively shallow were found to extend far deeper than expected. Even Jupiter's spectacular auroras raised new questions, as scientists discovered they are partly powered by material from Io, funneled along magnetic field lines in ways unlike anything seen on Earth. Rather than providing a final picture of Jupiter, Juno has shown how much remains unknown. Every answer has come with a new question attached. Jupiter has been doing this for 4.5 billion years. Long before the first oceans formed on Earth, it was already shaping the solar system, scattering, absorbing, protecting and destroying on a scale nothing else in our neighborhood can match. It will still be here long after everything we have ever built has disappeared. When you see it in the night sky, a bright, steady point of light, what you are looking at is not a distant decoration. It is the reason the solar system looks the way it does. And we are only beginning to understand what that means.